During this lesson, you will determine the number of significant digits a calculated number should have, round values to the correct number of significant digits, and identified, manipulated, and responding variables in an experiment.
When I left you at the end of our last program, we were in a bit of a mess. The results of our paper frog race were in doubt. After Derek, Sarah, and Bill calculated their frog speeds, Derek declared himself the winner, with the greatest speed of 4.704918 centimeters per second. But before we could award him the prize money, Sarah protested the results, demanding a recalculation. She claimed that Derek's answer was not scientifically honest because there was no way to get all those digits by measuring with a simple ruler and stopwatch using such a crude method of racing. Sarah wanted all the results to be rounded off, which might mean a share of the prize money for her.
What do you think? Is it okay to keep every digit from a calculator display screen? The answer is no. To be scientifically honest, in all calculations, you must round your answers off to the correct number of significant digits. Watch and see how we do it. Then we'll come back and see who really won the race. There are more rules about the number of significant digits allowed in certain calculations. Want to hear them? Okay. There is a better way. We can use common sense again. Put down your pencils and watch this.
All right, let's pretend there's this new disease called malpneumosis. The only way you can get the disease is by being touched by someone who has the disease. Now, if you're touched, you may or may not get the disease, but if you're not touched, there's no way you can get it. All right? Now, let's say I have the disease and I touch Andrew. Does he have the disease now?
We're not sure. It's uncertain.
That's right. He's uncertain. Now, Lindsay hasn't been touched by anyone. Could she possibly have the disease?
No.
All right. But now let's say that Andrew touches Lindsay. Now what about you, Lindsay?
Well, now I'm uncertain too.
That's right. Contact with someone who's uncertain makes you uncertain also. Now let's apply this idea to multiplying two measurements. First, tell me how many significant digits is in the first measurement.
4.
What about the 0?
It's significant because it's not holding a decimal place.
That's right. Now, what is the estimated digit in this one?
0.
All right, I want you to circle it to remind us that it's uncertain. All right, how many significant digits in the second?
2.
And which one is uncertain?
1.
Circle that. Now we're going to do something you haven't done in a long time. That's long multiplication. I already have it worked out here. And I want you to keep in mind that contact with an uncertain digit, just like contact with someone who has the malpneumosis germ, also makes that new calculated digit uncertain. All right, so the first thing we do is multiply the top line by the 1. Since it's uncertain, what do we know about all of these?
All 4 are uncertain.
All right, circle them all. Next, we multiply by the 2, which is a certain digit. So the only uncertain digit in this line is which one?
0.
All right. Now it's time to add. That's another opportunity for some more contact. We wind up with every digit except the 6 coming in contact with an uncertain digit. So circle all of these, all 4. Now that's 4 uncertain digits. But how many can we have and still be scientifically honest?
Only 1.
Only 1. So we're going to have to get rid of these, round our answer, and our answer will become?
6.6 meters squared.
That's right. Now you're probably wondering if you have to do this every time. The answer is no. All you have to do is look at your two measurements. Find the one with the least number of significant digits, which is this one with how many?
2.
And round your answer off to the 2. This is sometimes referred to as the weak link method. Find the weakest link. If it has 2 significant digits, you can only have 2 significant digits in your answer. But what about adding and subtracting? Are the rules the same? Look at this problem. The point 0.02 meters has only 1 significant digit. This 0 is a placeholder. So does that mean we have to round off our answer entirely to just one significant digit, making it 5,000? Let's circle the estimated digits, line up our numbers, and do some long addition. The 1 is estimated, and the 2 is estimated. The only contact with uncertain digits is the 2 and the 1. Since we can only have one estimated digit, we'll have to round our answer off to the first estimated digit, making our answer 5143.62 meters.
The rule for adding and subtracting is to round the answer to the first column containing an estimated digit. Your best bet is to arrange the numbers with the decimals lined up and scan from left to right until you come to an estimated digit. Stop at that place and round. We'll call this the weakest column.
In a moment, your teacher will turn off the tape and show you some problems. We don't want you to calculate the answers. Just look at the numbers and decide how many significant digits the answer should have. We'll go over them when you return. Good luck.
Local teachers, please turn off the tape and give students problem set 1